intriguing and direct. We interact with it every single day. Yet, for most of us, this invisible force remains a complete mystery. It decides what videos you watch, how your car drives, and even how to write the emails you send to your boss. But despite the hype and the fear, artificial intelligence is not magic, and it is certainly not magic dust sprinkled on a computer. At its core, AI is simply math, incredibly complex statistics designed to find patterns in chaos. To understand how it thinks, we have to look inside the structure of a biological brain which inspired the machine. Your brain consists of billions of neurons, tiny cells that pass electrical signals to one another to process information. Computer scientists mimicked this by creating artificial neural networks, digital layers that pass data forward. Imagine a neural network not as a brain, but as a massive, intricate machine with thousands of tiny dials. When you feed data into the machine, like a picture of a cat, that data travels through the gears. Initially, the dials are set randomly, so the machine has absolutely no idea what it is looking at. It might guess that the cat is a toaster, or a dog, or a cloud, because it hasn't learned anything yet. This is where the training process begins, and it is the most crucial part of building intelligence. We show the network the image again, but this time we provide the correct answer label. The machine realizes its mistake and calculates how far off its guess was from the truth. Then, through a process called backpropagation, it goes back and adjusts those thousands of dials. It tweaks the settings just a tiny bit, so next time it gets slightly closer to the right answer. Now imagine doing this not once, but millions of times with millions of different images. Slowly, those random dials tune themselves into a perfect configuration that can recognize patterns. The first layer of the network might just look for simple edges, seeing straight lines and curves. The next layer combines those edges to identify shapes like circles or squares. Deeper layers look for complex textures like fur, eyes, or the metallic sheen of a car. By the final layer, the machine isn't seeing pixels, it is seeing the concept of a cat. This is exactly how deep learning works, stacking layers of understanding on top of each other. But what about the AI that writes poetry or code? That uses a different architecture. These are called large language models, and they are built on something called the transformer. Think of a large language model as a super advanced autocomplete on your phone. It doesn't actually know what truth is, it only knows statistical probability. When you ask it a question, it looks at the words you used and calculates what word comes next. It has read almost everything on the internet, so it knows which words tend to hang out together. If I say peanut butter and, the model assigns a 99% probability that the next word is jelly. It's not thinking about a sandwich, it's simply predicting the most likely token in the sequence. The intelligence emerges because the model has billions of parameters or adjustable weights. The more parameters a model has, the more nuance and complexity it can capture from the data. Training these massive models requires supercomputers running for months at a time. The energy consumed during this training is often enough to power a small town. However, once the model is trained, it becomes a static file, a snapshot of knowledge. This is why AI can hallucinate, making up facts that sound plausible but are totally wrong. It doesn't have a fact-checking module, it just wants to complete the pattern you started. So is AI actually smart, or is it just a very convincing parrot? The line is blurring because at a certain scale, pattern matching begins to look like reasoning. It can solve math problems, write code, and pass bar exams all by predicting the next word. But it lacks one thing that biological brains possess: intent. The AI doesn't want anything. It doesn't care if it solves your problem or fails. It is simply executing the math that we programmed into it, mirroring our own intelligence back at us. As we make these networks larger, new abilities are emerging that we didn't even predict. This is the black box problem. We know how to build it, but we don't fully know what's happening inside.
We are essentially gardening, growing a digital organism and pruning it until it behaves. The future of AI isn't about building a fake human, it's about building a new kind of tool. A tool that extends our own minds, allowing us to think faster and see further. We are entering an era where intelligence is a utility available on tap like electricity. And just like electricity, it will illuminate things we never thought possible. The magic isn't in the machine, the magic is in the math that makes the machine learn. Understanding this removes the fear and replaces it with a fascinating reality. We have built a mirror that can think, and now we must decide what we want it to reflect. If you want more simple, clear explanations about AI and the future, subscribe and check out the next video.